Welcome to Mobility Learning Center. Dear students, today I will present you about the Charles law. It's grade 9 chemistry, unit 5 and part number 5. Okay, the Charles law relates volume and temperature. The name Charles law was given from the name of Jacques Charles. He is a French physicist. He was the first person to fill a balloon with hydrogen gas and made the first solo balloon flight. He was a balloonist. Okay? Jacques Charles investigated quantitative relationship between the volume and temperature of a fixed quantity of gas, which is at constant pressure. Okay, look at this picture. This one is a balloon in normal water. This one is a balloon in hot water. This is a balloon in cold water. Okay, the balloon in hot water becomes what expanded, but the balloon in cold water is inflated, deflated. Okay, this implies what? The direct relationship between pressure and temperature. I mean volume and temperature. The volume increases with an increase in temperature. Look at the picture in the balloon in hot water. The volume increases and the temperature also what increase. But here, as the temperature decreases, the volume of the balloon becomes decreased at constant atmospheric pressure and under the same amount of what the gas. Okay, the real life examples of the Charles law. The Charles law is a gas law, relates volume and temperature. Examples of real life of the Charles law, for example, hot air balloon, the human lungs, full floats, ping pong balls, tires. In summer, tires get inflated. In winter, tires get what? Deflated. In 1848, Lord Kelvin realized that a temperature of minus 273.15 degrees Celsius is considered as what? The absolute zero. The absolute zero temperature is 0 Kelvin, which equals to minus 273.15 degrees Celsius. The absolute zero is theoretically the lowest attainable temperature at which the volume is zero. Then he set up an absolute temperature scale or the Kelvin temperature scale with absolute zero as the starting point on the Kelvin scale. The average kinetic energy of a gas molecule is closely related to the Kelvin temperature. A direct relationship between average kinetic energy and the absolute temperature. According to the kinetic molecular theory of gas, the kinetic energy of a gas is directly proportional to the absolute temperature. That means the Kelvin scale temperature. The volume of a gas and Kelvin temperature are directly proportional to each other. For example, doubling the Kelvin temperature causes the volume of a gas to double, and reducing the Kelvin temperature by half causes the volume of a gas to decrease by half. The relationship between Kelvin temperature and the volume of a gas is known as what? The Charles law. Charles law states that the volume of a fixed mass of gas at constant pressure and amount of gas varies directly with the Kelvin temperature. This is the graph that shows what? The direct relationship between volume and temperature, okay? Temperature in Kelvin scale. The graph is drawn by using what? Volume versus temperature in Kelvin, okay? Direct is a linear graph the direct relationship between the Kelvin scale temperature and the volume, not the Celsius or the Fahrenheit scale temperature. But it is what volume is directly proportional to the Kelvin scale or the absolute uh, temperature. Okay, as the temperature increases, the volume also what increase. As the volume decreases, the temperature also becomes decrease. This table also shows that the relationship between volume and temperature data for a gas sample at constant amount and pressure. Okay, the first column indicates the volume. The second column indicates what the temperature. When you divide volume to temperature, it gives what constant number. Constant number. Okay, this indicates V over T is constant. V over T is constant. Okay, volume, according to Charles' law, mathematically related that volume and temperature related as what? Volume directly proportional to temperature at constant pressure and amount of gas. Volume equals to K times T. Okay, K is a constant number, or which equals to V over T equals to K. Okay, as we have seen here in the graph, volume divided by temperature gives what to volume divided by temperature again gives what to. This is the constant number K. Okay, this implies V1 over Q1 is constant and V2 over T2 also is constant. V3 over T3 equals to what constant. From this, we derive the formula V1 over Q1 equals to V2 over T2 at constant pressure and amount of gas. Examples. Example number 1, a gas is collected and found to fill 2.85 liter at 25 degrees Celsius. What will be its volume at standard temperature? Given we have Q1 2.85 liter, Q1 is 25 degrees Celsius, T2 is 0 degrees Celsius. 0 degrees Celsius is the standard temperature, which equals 273 Kelvin. And you are asked to find the volume V2. Solution: first convert the Celsius temperature into Watt Kelvin. All calculations in gas law must be calculated by using the temperature in Kelvin scale. You get 298 Kelvin, okay? 0 degrees Celsius plus 273. Okay, sorry, the Q1 is 25 degrees Celsius. 25 degrees Celsius plus 273 gives 298, and T2 is 0 degrees Celsius plus 273 is 270. Then apply the formula V1 over Q1 equals to V2 over T2. V1 is 2.85 liter over T2, 298 Kelvin, which equals to V2 over 273 Kelvin. Because you are asked V2 to calculate the V2, and V2 is represented by X according to our example, and then crisscross and divide by 298, and you will obtain 2.61 liter. This is the first example. The second example is, this one is the second example. This is the second example. If 5.00 liter of a gas is collected at 100 Kelvin and then allowed to expand to 20 liter, what must the new temperature be in order to obtain the same pressure? Okay, the pressure is the same. The amount of the gas also is what constant, but the volume and temperature are variables. Okay, V1 is 5 liter divided by what? Q1 100 Kelvin, and V2 is 20 liter, which is divided by what? T2. And crisscross and divided by what? 5 liter. This gives 400 Kelvin. The example, at what temperature will the volume of a gas be doubled at constant pressure if the original temperature is 17 degrees Celsius? You have original temperature which equals 17 degrees Celsius, and assume V1 is V and T1 is 71 degrees Celsius plus 173, because the Celsius temperature must be converted into what? Kelvin scale, which gives what? 190 Kelvin, and V2 is doubled, okay? 2 times V1, which equals 2 times V, and apply the Charle's law, which has an equation of what? V1 over T1 equals to V2 over T2, and rearrange this formula to give T2 equals to V2 times T1 divided by V1. This gives 2V multiplied by 290 Kelvin divided by what? V. This gives 560 Kelvin. Okay, this all about the Charle's law, the second gas law. Thank you for watching. See you later. Bye bye.